Well, thank you everyone for coming, and good afternoon. My name is Bethany Chris, for those of you that do not know me. I'm the Transportation Safety Manager here at Eastgate, but I also work in our GIS and environmental programs as well. I'd like to introduce my partner, who actually just took off, Justin, who you'll see doing the IT stuff. He is a planner in our transportation, environmental, and GIS programs also. And we wanted to hold this event because harmful algal blooms are a very serious issue that isn't being talked about enough here in the Mahoning Valley. And I think it's not being talked about enough because we've been lucky and we haven't had an event, but our neighbors, especially Lake Erie to the north, have. And if you've been paying attention to the news in the last several years, actually longer, many regions across the U.S. are having issues with harmful algal blooms. So since Justin and I are GIS professionals, we wanted to see how technology can help monitor and prevent this problem. In any agency, there's going to be time and funding limitations with field work, so GIS will allow us to expand our monitoring power. So we wanted to get ahead of this issue and begin the discussion with our members and partners, which are you guys, so we can understand what harmful algal blooms are, why they happen, and what we as planners, engineers, public officials, water operators, GIS analysts, education professionals, and volunteers can do to prevent this and to monitor the problem. So towards that goal, I've invited three, can you hear me back there? Okay. I've invited three very interesting speakers here today. Mandy Razzano, right there, hi, is an environmental specialist with the Ohio Environmental Protection Agency Northeast District, which is our district. So she knows more about water quality in our region than anyone else. She will educate us on what harmful algal blooms are. Thank you.
I don't know how you want to, do you want to hold it?
Sure. Can you hear me now? Okay. Mandy will educate us on what harmful algal blooms are, how EPA monitors them, and we'll also talk about her graduate work using Landsat satellite imagery to monitor water quality. Dean Barbeau is also here with us today, is a project manager at Civil and Environmental Consultants. I met Dean through a GIS user group in Southern Ohio that we are both involved with, and when I heard what project he was working on, I thought it'd be valuable to have him come and talk about the GIS public education tool that he's creating for Lucas County, which includes the city of Toledo on Lake Erie. Dean will talk about the web-based GIS tool, which identifies water quality data for the county and impairment sources which need to be monitored and controlled to help prevent harmful algal blooms in Lake Erie. We also have Dr. Rafat Ansari is from NASA Glenn. He's a senior scientist there. He's known for achievements in biomedical optics, optical, photo-optical, optoelectric applied science, and experimental ophthalmology. He's worked with NASA to advance light scattering technology for space experiments aboard the Space Shuttle Orbiter and Space Station, and has applied these breakthroughs to biomedical applications here on Earth. But we're actually talking about a different project of his. He's also a pilot, and he started a citizen scientist campaign to monitor water quality. And he and other volunteers fly Lake Erie and interior waterways, taking much needed true color and color infrared aerial photography of Lake Erie and the inland waterways. With GPS-enabled cameras on their aircraft, they take photos, they house them at Cleveland State, which is accessible to all. And the photographs are used to monitor changes in water quality. It's also his 42nd wedding anniversary today. So congratulations and thank you for coming. So that now you know a little bit about us at Eastgate and our speakers, I'd like to do quick introductions around the room so that our speakers know who they are addressing today. I guess we'll start right there.
Well,
You guys?
Rafat Ansari, as she said, from NASA Glenn. And yes, it's 42nd anniversary. What a beautiful way to spend the year. Talk about numbers. Can get more romantic than that.
My name is Ansari, and he had introduced me already.
Shane Burkholder, Cook County Planning Commission.
I'm Mia Hall, I'm with the Environmental Consultant. I'm Stephanie Dyer, I'm with Eastgate. also Burns, graduate student at Penn State.
Greg Moore with Ohio EPA Northeast District.
Bobby Taylor.
As well, Ohio EPA. Same copy.
Justin Moldock with Eastgate. And Davis with Eastgate.
Meanwhile, Ellie, State. Monterey, Chapman, State. Julie Ross, Landsat.
Jeff Murphy, Mahoney County GIS.
Allison Sherlocker, Star Parks.
Jim Kitty, Director of Eastgate.
Andrew Steingus, Northern Metro Parks.
Tom Holloway, Ohio Valley Sanitary District. Roger Harrison, SBS.
Defect Kiboso, YSU.
Jennifer Johnson, Aqua, Ohio.
Tom Buckler from ODOT.
Rebecca Rogers, Poland Village.
Karen Ho, also from Poland Village.
Dean Barbo from Civil Environmental Consultants.
Hello, I'm Greg Hines. I'm a civil engineer with Tetra Tech.
Thank you, everyone. We also have a live stream going on YouTube, so we have a few people joining us there as well. And before we get into the presentations, just a couple announcements. Food, as you've seen, please help yourself. We have coffee in the kitchen, which is straight back through the doors there. Men's restrooms are to the left here, and women's are back to the right. And on the agenda, there isn't a break scheduled, but after about an hour, we will stop and let you stretch your legs and grab some more snacks. So with that, I will turn it over to Mandy.
Thank you, Bethany.
That's on.
I'm pretty loud. We'll see. Okay. Okay, well, hello, my name is Mandy Razzano, as Bethany introduced me, and I'm going to talk to you today about, first of all, we're going to talk about monitoring the water quality of inland lakes, and I'm going to talk about our Inland Lakes program at Ohio EPA through the Division of Surface Water, not to be confused with the Division of Drinking and Groundwater that regulates public drinking water systems. And then I'm going to shift gears a little bit and talk about remote sensing. I did that kind of work for my master's thesis at Lake Rockwell for Akron. And I'm just going to give like a remote sensing 101 kind of, and just show you a few slides about remote sensing. Okay, harmful algal blooms, right? The big HABs thing that everyone's talking about it. It's definitely ever since Toledo happened, and people, I can't remember the number of people, but there is a serious amount of people without drinking water. More and more people are wanting to know more about it and ways that we can monitor it. Satellite imagery is a cheap, easy way to predict and locate harmful algal blooms, and then also to implement an action plan. So on the screen I have microcystis, which is the rock star pretty much, but Anabina is also another cyanobacteria that it's more of a nitrogen fixer, so that's one that they're really concerned about because it can fix nitrogen from the air, which it doesn't need the pollutants in the water to start growing and producing the toxin. They don't really know why the toxins are produced. I've heard some research that it's like a ratio of the phosphorus in nitrogen, but I don't know, if it was preliminary research, so I don't know for sure. But a lot of people are working on it, that's for sure. So microcystin is the toxin that is produced. It actually is produced by both of these, microcystis and Anabina. These are just two of the cyanobacteria that have been causing problems. 2 years ago now, I unfortunately documented saxitoxin, which is a neurotoxin. Microcystin is it's a liver toxin, but saxitoxin is a neurotoxin that is produced by a few different cyanobacteria, and I think they actually thought it was kind of rare, but we documented it at Barberton Reservoir, which is west of Akron. So it was a big scare when this happened because there was not a lot of research on it. There was no thresholds or anything. So we went out and sampled it rigorously, trying to figure out who's producing it, what cyanobacteria populations were in the lake, where were they growing, and possibly what we could do about it. So that's just some history behind what's been going on at the EPA like for the past 2 years. But I'm going to talk about our inland lake program, and I'll discuss how we sample lakes for Division of Surface Water. But of course, the water treatment issue with Division of Drinking and Groundwater, they regulate water treatment plants. And I think it was this past year I think it was July, all water treatment plants in the state of Ohio had to start monitoring for toxins at their raw intake and at their finished water every other week. And so when there is a mass production of algae even, all the organics come into the plant and they cause other problems besides the toxin. You can have taste and odor problems from high organics, and then disinfection byproducts are produced out into the distribution system. So it's not only problems that are happening within the plant, there's problems happening out in the distribution system also. It causes filter clogging when large algal blooms are produced. And then, of course, I don't know if Youngstown has had a lot of taste and odor problems, but I know Akron has. And there's a ton of, complaints called into the water plant, and, so when there's a toxic event that occurs, they have to up their carbon, which is very expensive. So it's a lot of money to the community. I think that Akron told me if they were to have a massive algal bloom, it would cost them it possibly could cost them $7,000 a day to treat it with the carbon. Because the better the carbon, of course, the more expensive it is, the better it treats the toxin. Okay, so then we also got recreational uses that are a major problem when there's a harmful algal bloom. Back in 2010 was when this all blew up with Grand Lake St. Mary's, which is a large lake on the western side of Ohio. This picture actually here is from West Farmington, which is a small community in Trumbull County that had, I think it was microcystin hits. And we went out and sampled their little small reservoir that they draw water from the Grand River. And we tried to help them, but eventually Division of Drinking and Groundwater helped them work through their problems, and I think they're still going through, I think they're actually going to be connecting to another water system to assist them if they have harmful algal blooms in the future. So of course, the toxins are produced, it restricts people from using their public waterways, and then also it causes adverse effects on aquatic life, because we can have large fish kills. And so this is where you can get your information. If you want to go, kayaking somewhere, you could go to the Beach Guard. And this site is through the state of Ohio, Department of Health. We work with them, and we post advisories on there when either the Division of Surface Water or somebody else has documented a HAB. And of course, you have bacteria alerts also. So you have the recreational alert, and then you have the elevated recreational public health advisory. And Grand Lake St. Mary's, I think, is always, it has 2 reds on it still, and I just got this the other day. So they have been, really in the media, and they've done a lot of research at their little water lab, trying to find ways to quickly identify it and what to do with it. It's it's the largest lake in Ohio, other than Mosquito is the second largest lake, but it's very shallow, and there's agriculture there producing a lot of nutrients that cause the problem. So again, I work for the Division of Surface Water, and we have an inland lakes program that monitors. We're more concerned with aquatic life impairments rather than drinking water. We assist them. We collect data for the Division of Drinking and Groundwater. but our main purpose is to look at lake habitat use, to see how well the lake's doing in relation to the aquatic life. Oh, and this is our manual you can find online. If you are interested in what we do, and you maybe want to even take your boat out on Mosquito Lake and do some sampling for your own self, you may want to do that. I've done it before when I wasn't at work. So, okay, so what we do is we do a 2-year survey of a lake, and we sample 5 times per year. So we have 10 samples at the end of 2 years. We do water quality profiling, chemistry at the surface and bottom, water transparency, chlorophyll A, phytoplankton and zooplankton, and sediment. And I'll go through each of these and explain how we sample. Okay, so we have a water quality sonde that measures a variety of parameters, but this is just a DO profile. As you can see, there's depth on the y-axis, and on the top x-axis there's dissolved, DO in milligrams per liter. And so as you can see, this lake, which is Coe Lake, this is the drinking water lake for Berea. It's actually their second, their backup water source. When it's horrible, but the chloride levels from road salt get so high in the Rocky River that they have to use this lake as backup because they can't meet the MCL for chlorides in their drinking water if they're using the Rocky River during the winter. But anyway, so as you can see, this lake at the top, so this would be at half a meter below surface. There's good oxygen levels, and then the lower you go, it gets stratified in the summertime, and we go to anoxic conditions in the hypolimnion. And so these are the locations that we sample when we're at the lake. We sample at half a meter below the surface and a half a meter from the bottom. Typically, when the lake's stratified, especially to see the difference in water chemistry from the top to the bottom. And this is a lot of problem. This is a problem when lakes are stratified, and the intake for the drinking water is at a certain depth in the lake, and they can't alter that depth. So it's always good to make sure that we have information throughout the water column. Because our main priority when we pick lakes to do, like every year we do, get a new rotation, and we try to do public drinking water reservoirs. That's our priority now, within the watershed that Division of Surface Water is doing their survey. Okay, our chemistry samples that are collected at the at half a meter below the surface and half a meter from the bottom of the lake. We use a Van Doren, and I brought it just for fun to show you, if nobody has played with one before. So what this instrument does is it will be able to collect water at any depth. And we had some intelligent interns that were able to put like a Roman scale on this rope. You lower it down to, this is half a meter, and then you drop a weight, and it'll close and right at half a meter, it'll close it up from the weight, and you collect water at that depth. So that's how we get the depth of samples. It's as accurate as you can do it. And so of those samples, we analyze nutrients, metals, and some non-preserves like total dissolved solids, or suspended solids, and then we also take the algal toxins. Okay, and then we do transparency with the SETI disc. And this is something that anyone can use. I will introduce a program later that is a volunteer program called CLAM, but this has been around since the 1800s, if you can believe it. And you lower it, as I say, it's supposed to be collected between 10 a.m. and 4 p.m., measured from the shady side of the boat. We have our amazing intern there in the photo taking the measurement. No sunglasses. And you lower it down until you can't see, until it's not visible. You put a clip on the string, you lower it down just a little bit more, and then you pull it up until it's visible, You put another clip on there, and then you take the measurement in between there. And that is the measurement of transparency, or, you know, how almost, I guess it could be determined as like the photic zone where light can reach. So that information is very valuable for looking at phytoplankton. Because of course they are a phyto, you know, they need the light. So we have to make sure that when we do chlorophyll A, so chlorophyll A of course is a pigment present in all algae and cyanobacteria. So it's a great indicator for algal production. And we collect this sample at twice the depth, at the depth twice the sucky depth. And then we filter the sample and we send it to our lab for analysis. Chlorophyll A is used to determine biomass by a lot of research uses it. It's definitely a good parameter to have when we're looking at production. And then we take the phytoplankton sample. Phytoplankton is collected with an integrated depth sampler, which, as you can see, it's just like a straw. There is a stopper at the top, and so we will collect it at double the sucky depth, unless it's 2 meters. Then we go 2 whole meters if the sucky depth is more than 2 meters. Then we preserve it with iodine, and then we send it away to BSA, which is a phytoplankton identification lab in Beechwood, and they give us numerations and cell counts. And there's all the different types of phytoplankton. As you can see, cyanobacteria actually is not algae, but everybody just generalizes it with algae. It's actually a bacteria. But there's lots of different kinds. So we get a whole count of all of the critters that are there. And these are microscopic organisms that cannot be seen with the naked eye. Unlike zooplankton, we do collect zooplankton, but unfortunately I have a whole cabinet of samples. So if anybody is interested in zooplankton, you could get in touch with me and I would give you some samples to analyze. Like the picture of the rotifer right there, the University of Akron actually has some of my samples now, and they're going to be letting grad students identify them. So over there is the different types of zooplankton. So all of these phytoplankton and zooplankton, they all play a big role in the aquatic life diversity within the lake. We also take sediment samples. Unfortunately, we don't have regulation for sediments. In Ohio, we don't have any regulation for them, but they give us valuable information about phosphorus that could potentially be stored in the sediment. As you see, my coworker, Greg Orr, we were using a gravity core and collecting cores. I think that was at Summit Lake in Akron. We also use a Ekman dredge, which is just like a little scooper that pulls up a sample. But with the gravity core, we know the exact depth that we're sampling from. And so we typically analyze it, like I said, nutrients, metals, TOC, that's total organic carbon, and pH. Oh, this is what I was talking about earlier, the CLAM, Citizen Lake Awareness and Monitoring. So if you know anybody that lives on a lake or would like to monitor a lake, this is a really cool program. And it's sponsored and supported by Ohio Lake Management Society, which is a really cool organization. You should look them up. And so they train citizens to go out and take lake information, and then they post it on their website. They have a really nice database. Okay, so now I'm going to switch gears and talk about remote sensing. Just to give you a little introduction, I'm sure we will have the speaker later that will go into it way more in depth. So remote sensing is collected by satellites. It collects electromagnetic interactions that in these sensors that are on the satellite, and then they are referred to as bands. So the sensors isolate and measure the certain wavelengths of energy, and then that is converted into bands, and that's how we utilize the data. It all depends on the angle of inflection of the sun, and there's lots of different things that go into the value of either the wavelength being reflected or absorbed or scattered or transmitted. And so the spectral reflectance of water, of course, is affected by these characteristics of the physical, turbidity, chemical. Unfortunately, the picture farthest to the left is runoff from a large salt pile. It was so corrosive that it ate away part of the storm drain. And so turbidity, like the stream at the bottom, or again, the algal, the biological at the top right. Yeah, it's your right. Okay, I'm just going to talk about 2 satellites, just to give you, these are 2 satellites that's been used in the area. MODIS, I'll talk about a little later, is used by NOAA, and they monitor Lake Erie with it. I'm going to talk about the spatial, temporal, and spectral resolutions of these 2 satellites, and then Landsat, of course. So the spatial resolution is how big the pixel is. So you can just think about like when you buy a camera, 7 megapixels or whatever. So that's how big the pixel of the image would be. Temporal is how many days does the satellite come back and take the photograph. And then the spectral is how many bands. So if there's more bands, they get more finite information than larger bands. At the bottom, I have a graphic that is from Landsat. As you can see, the bands are pretty large on the electromagnetic spectrum. This is reflectance level. And it shows you that there's characteristics of different kinds of reflectance. The vegetation has a certain reflectance, and water. Those are very, very distinct characteristics that can be picked up with satellite imagery. Okay, so I'm going to go into a little bit more depth just to give you some knowledge about these.
Sorry.
Go right ahead. So this is Landsat 7. And so these are the 7 bands. And that's the range of which, like the blue band, the green, and the red on the electromagnetic spectrum. And then, again, the spatial resolution. So each pixel is 30 meters by 30 meters. And that makes it applicable to small inland lakes, where a lot of satellite imageries, these pixels will be like 1 kilometer by 1 kilometer. They're huge, so we can't even use them in a lot of our inland lakes. That's the problem. That's why taking photographs from the airplane is way more applicable to smaller water bodies. And then, as you can see, over on the far right, I have which band. So blue, of course, water bodies, green, vegetative health, and of course the red, vegetative discrimination, and then the near-infrared red, water land contrast, and crop identification. These are uses that people that utilize the satellite imagery use them for in their research. Okay, so temporal resolution, again, this is how often, the speed of the satellite, like does it come back every 16 days? And that's the problem with Landsat. As I had said here, every 8 to 16 days it comes back, whereas MODIS comes back to every 1 to 2 days. So that's why, what about if it's cloudy that day? They say that half to 2/3 of the images are cloudy. So when you're doing this research, it's like so time sensitive that, you got to know the time that the satellite's flying over. Is it cloudy? You got to be out there to take the sample. The research is very time sensitive. Hence, it took me 7 years to finish my master's thesis. But you all know it takes sometimes a while. But and so sometimes though you'll get an overlap. Like if you're on the edge of the image, there'll be another one that passes over next to it. So you'll have like one every. You'll get doubled images if you're lucky, if that's where your research area is located. Okay, and so for Landsat, this is the path and rows for Ohio. This is how the images are identified, just to show you, just give you a graphic to see how big this image is in Ohio. Put it on our state. And so, you could be identified as if, you're up in Ashtabula, you'd be on row 31, path 18. And when you download that data, you'd know which image to request. And so these images are free. Landsat is free. And of course, there is a lot of other satellites that are commercial that you can buy images that have, you know, really good temporal resolution or very good spectral resolution and all that, but with the free images, it seems like you either give up one or the other. Like they either come around a lot, but they have a high, you know, a large pixel size or a large, you know, picture size, or, you know, the opposite. So you can get these on Earth Explorer. USGS archives all the data for NASA. Okay, so satellite image analysis. Once you download, the images are downloaded with each individual band at one time. You download band 1, band 2, and then you merge them together in, I used Geomatica software in grad school. So you would have to purchase software to do that. And then you clip it down to your study location, and all images have to be atmospherically corrected based upon, you know, scatter within the atmosphere, different aerosols cause the values to change, and then you have to do radiometric correction, and then an algorithm analysis to determine, like, if I'll show you 2 different algorithms. They're very commonly used that a lot of people use for their research. So the first one I'm going to talk about is NDWI, and this is just a very simple algorithm. You take the value from band 4 minus band 5 divided by 4, or 4 plus 5. And that value will produce an image that shows you water versus land. So you can see flooding. A lot of people that do flooding use this kind of algorithm in their research. Now in my research, I used NDVI, which it's typically used for vegetative health, but I attempted to use it on a water source to look at chlorophyll A levels, which presented me with interesting challenges with my results. But again, it's a very simple math problem that, you know, the computer does for you. The Geomatica did it for me. And so the values that you get are -1 to 1. And then it tells you, if you use it on land, it'll tell you vegetative health. So a lot of people that are looking at, like, let's say they're looking at tree health in the Amazon rainforest or something, they would use this algorithm to, as a simple way to look at an image and get a percentage of, you know, stressed vegetation versus healthy. And so these were images that I analyzed for Lake Rockwell for my thesis. And as you can see, the NDVI values were -1 to positive 0.5. And so what I would do is I'd go out and collect a chlorophyll A sample. Akron Water Supply would analyze the sample for me in the lab, and then I took that exact location, the Latin long, and then I'd look at the pixel value, and then I'd compare it. So my results were rough because, first of all, this is used on land, and land and water have opposite reflection on the electromagnetic spectrum, so I had a negative correlation. But I did a few other things in my thesis that I got positive results for, but I think that a lot of places, I think even the Army Corps of Engineers, maybe, or who was it, said recently that they are developing an app, and you will just be able to download an app, and it will tell you, you know, if there's an algal bloom and how significant it is. Okay, and then MODIS is the one that is used, the satellite that is used by NOAA for the experimental Lake Erie harmful algal bloom bulletin. Does anybody know of this bulletin and use it? Yes, it's a very good tool for the communities that that get their drinking water from Lake Erie, it has a predictive index, and their website's really cool. I highly recommend checking it out. I get an email. You can sign up to get an email, and it'll send you results. I think, is it once a week I get it? But I know people who work for Cleveland Water, and they use this extensively. It's a big help for them. And so MODIS, of course, they have 36 spectral bands, so you get a lot more information with their images. But again, their pixel size is 250 meters to 550 meters in size. So you could not use it on a small inland lake like Meander Reservoir. You know, it's just not going to work. And again, so, you know, they come around one every 2 days, which is way better than Landsat. I have spectral bands on their choice. Okay, and so other states have used, you know, Landsat. This is from 2004, but large-scale monitoring of the whole entire state of Michigan was done by the USGS, and they looked at sucky disk transparency and chlorophyll A measurements with Landsat. So this is, you know, used on large scale, you know, for small inland lakes. And I don't know of any large scale research that's been done on Ohio lakes with Landsat, but I'd be interested if anybody else knew, because it's definitely a very quick and easy way to determine what's happening in the lake, especially if you're a drinking water treatment plant operator and you are, you know, having to worry about constant sampling of the toxins and reporting back to the Ohio EPA Division of Drinking and Groundwater. Okay, that's all I have. Does anybody have any questions? Come on. You know you do.
The CLAM program, what would volunteers monitor? What parameters would they?
Some they will train you to do with the sucky disc and then chlorophyll A. Okay. And then if you want to do more, I think they would train you to do it if you had the instruments. Okay. Yeah, Ohio Lake Management Society is a very good organization that collects data. And I've been on there, and the amount of lakes that they sample, it's intense. So you can go on there and look for a lake that's by your house. You know, if you live by Lake Evans or wherever, you know, you could go on there and look for data. Because a lot of people, you'd be surprised, probably people are collecting data at the lake already that you even maybe want to collect data at. So I was surprised, that's for sure. I know somebody else has questions.
The data that they sampled at Lake Management Society, do you know if it's like a vetted as far as like a quality control or anything?
Well, I don't think that they have. I think if it's the same person doing it all the time, that's the thing with volunteer data, right? Yeah. It's like if you have the same person doing the same measurement all the time, that's your QAQC with volunteer data, I think. You know, and same with the sucky. They say that it's better to have the same person always collecting because it's a very subjective, you know, some people's vision is not as good as others. So if you have the same person collecting the information every single time, it's more reliable. No other questions? Okay, thank you for your time.
Dean, you are up next.
Thank you. Thank you very much.
Good afternoon. Hi, my name is Dean Barbo. I'm with Civil Environmental Consultants. I'm out of Columbus, Ohio. We also have an office in Toledo, Ohio, which is how this kind of led into this project. We have some of our staff in Toledo have good relationships with Lucas County. One of my colleagues, Tim Murphy, used to work for Lucas County, and he was able to talk to them after they had the harmful algal bloom incident in Toledo, which left somewhere around 500,000 people without drinking and bathing and cooking water for 5 days. That was pretty serious by any stretch of any measure. That's a lot of people, a lot of voters, a lot of citizens that were up in arms about why did this happen. You know, most people don't think about what's in their drinking water most of the time, and then when they all of a sudden you can't drink your water anymore, for the next, until we say so. That's a big impetus and motivator for change, for action. So, to the vision of the Lucas County Commissioners and to the Mayor of Toledo, they've all gotten on board and saying, well, let's address what this is. You know, they've done a great job. They've gotten a lot of money, in the tens of millions, to upgrade their drinking water facilities in the Lake Erie and in the Maumee. And that's, you know, treating a symptom. The fact that is that it's still high levels of bacteria and algae in the water. And it's causing all kinds of problems as far as their filtration and you name it. So they wanted to take a very proactive approach and try to address the causes of the high bacteria in the water and the algae in the water. So that is a wide-ranging, multi-faceted problem across the entire region. And what we did is when we started to look at this, and they hired us on to take a look at what could be the possible causes of the algal blooms. And a lot of it is just, okay, well, what's out there? What do we have? What do we know? And that's a big question unto itself. So that's where we started, is, okay, what are the potential causes and sources of the algal blooms? So we started to look at that with, the place you always look first when you start looking at drinking water is and water quality is the EPA. So they're the gatekeepers, the arbiters of the data. They have everything in there. They do the sampling. They do the monitoring. They hold the standards of what they do. And we were able to gather all that data together. Everything that's in this system is publicly available data that we were able to either collaborate through the various environmental EPA regions and through the state, and then we were also in Michigan and the Indiana Department of Environmental Quality, and looking at animal plant CAFOs, the concentrated animal feed operations, the NPDS permits that are going to be all in place across the region. We were able to gather all this data into a application across the landscape of Western Lake Erie Basin. And when you're looking at large landscapes and data across a large area, there's one tool that's great for doing so, and that's GIS. GIS has revolutionized a lot of the ability to analyze data across a landscape. So that's what we decided to use with this, because most of the data that's collected nowadays has a spatial component. It's collected at a location on a stream that has an area and it goes from here to there. So it's all spatially related and comes together in maps. And by now, very many of us are very familiar with online mapping at this point. There's Google Earth, which is a great tool, and there is ArcGIS online, there's ESRI, there's other tools for doing so. And people are getting very familiar with using these tools in their day-to-day usage, in their day-to-day work. I use it all the time. So what Lucas County hired us to do is to try and get all this together and try and understand what the causes are. So we started to gather the data for Lucas County. Lucas County is, just the one county in northwestern Ohio. This is the intro page for there. Whoops, it's the wrong one. Let's go to the other one, the other tab. Let's start here. Let's go home. All right. So so we started to gather the data together, and Lucas County is just one of the counties in northwestern Ohio, right at the mouth of the Maumee. And as we started to look at the data, we also brought on board various regional watershed agencies and coordinators to try and figure out, okay, what's the best way to approach this? And we all came to the same conclusion. Well, it's not just Lucas County. It's the Western Lake Erie Basin. All the water that flows into the Western Lake Erie Basin is the issue. Lucas County is in control of Lucas County. But they decided that, it goes over state boundaries, it goes over county boundaries, but yet we got to do something about this. And they were very responsive to the demands of their citizens to do something about it and to try and get something going to address the potential sources and causes of the algal blooms. So we expanded the analysis out to the entire western Lake Erie Basin, which is a daunting data set. It's a large area of data to collect. You got a lot of streams in there. You've got a lot of farms. You've got a lot of sampling data. There's a ton of data. So and they said, well, this is the best way to display this. Now, when we started to put this together, we were going to make a report of everything and just kind of give them a static paper report with some maps in it and be done with it, But we decided that I had conversations with the county, and we all came to the conclusion that that's not really going to help anybody in the long run. So we decided coming with an interactive approach through the online mapping tool and do the report basically in the map would be a better way to present the data and provide much more ability for future development of the analysis. So we went ahead, instead of making a report, we put together something called the story map, which is for the basic user, the beginning user is going to come into this website, and all of this data, let me sidebar here, all of this data is going to be right on the front page of the Lucas County website and in their environmental quality site as well. So we're in the process of porting all this data over to them, and they're going to be hosting it. And we have the keys to upgrade and change as needed. But we have, but this is a storyboard for the average citizen to come in and be able to understand a little better what's going on with their watersheds and their drinking water, and then can look at even the areas they want. And then we talked about in the previous presentation about citizen monitoring. That all can be incorporated into this, or if there's someone has an interest in their stream that they've been monitoring, they can look and see the data that's surrounding their area without having to go out searching all through the internet to find that data. Now, in putting all this together, that was the biggest hurdle. The biggest hurdle of all was gathering all this data together and getting it into a place where it's accessible. Because a lot of the problem with the data that the EPA has, which is very exhaustive, but accessing the information is not so easy all the time. So you have to have a good knowledge of how to access it. You have to have a good knowledge of what you're looking at. And most citizens really don't have that knowledge on hand. I mean, a lot of professionals that look at this information can easily get to that answer, but other people have a hard time doing so. So we wanted to be able to come and bring that to them. And that was, again, the biggest hurdle, was gathering all this data together and boiling it down to make it understandable as possible. So this served as our report. So we have a live web map with the explanations of all the things in the web map to help citizens kind of walk through it and understand it. So the guidance manual. We have the guidance manual of the Western Lake Erie Basin Nutrient Sources Inventory. I'm not going to read all this stuff here, but it's an inventory and mapping tool that identifies causes of impairment and potential pollutant sources that need to be controlled to achieve desired nutrient load reductions. The guidance manual includes pertinent information about the nutrient source inventory, and reviewing it prior to accessing the inventory will allow the user to maximize the amount of information he or she can obtain from the nutrient source inventory. Intro, says here's what it is, and then then they can kind of advance right through this to try and understand, okay, what data are we looking at? Okay, this is a basic project overview. I'm not going to read all that. That'd bore everybody to death. And then, but the first paragraph has got all the pertinent information. The goal of the first phase is to identify potential causes of impairment and pollutant sources that need to be controlled in order to achieve the desired nutrient load reductions, 40% load reductions as outlined in the 2016 Great Lakes Water Quality Agreement. So we're trying to help them get to that point. This is just the beginning, but it's expandable and adaptable to get us to that point. So people can read through these and understand better what it is that this is doing. All right, we have a user tutorial on here. So this is a video which I won't play now because it's 20 minutes long and we only got 30 minutes, and it's not real exciting. But it teaches people how to use the web tool in a video that's embedded directly into the document, and they can just watch it on their home computers and try and understand what's going on with the Western Lake Erie Basin. So we're going to be remaking this video to be a little shorter, and we're going to have an introduction from the Lucas County Commission, one of the Lucas County Commissioners, and the Mayor of Toledo is going to do the intro, and we're going to walk people through using the application. Slow connection. All right, so next one here is study area watersheds. So this kind of describes what watersheds are to the average person. Again, people generally don't know what watersheds are. I mean, they hear that word and they don't know what the definition of it is. And we help them out here with a link that kind of goes to the USGS definition of what they are and kind of tells everybody about what is a watershed. All right, then we start talk about some of the data that we put into this system. All right, so we have, we've put in here all the NPDES permit data, which the EPA has a site that does have this information in it already. However, we've got quite a bit of other data sets that they did not have available because it's interstate or not run through the EPA. So we were able to put all the EPA data in here for the NPDES permits and symbolize them as such and detail who and what the owners of those are and be able to see them. And additionally, you know, the data itself, hopefully this one has a link. Let's see. Link to the report. So you can pull up the report itself from the EPA website. So that's they can actually live link to the report and look at to see what the nutrient limits are for that individual permit. So it's the actual permit for that. So anybody who wants to look at these things can look at these things, and it's all available. And it's available on the EPA website. Finding it is the hard part. Is digging through all the data for an average citizen is daunting. So this helps them dig through data a little better, and a little faster. All right, and in there we've got the links to the different states. So we had to pull in data from Ohio, Indiana, and Michigan. So it's not dealing with one state's methodology of collecting data and reporting data. You got to deal with multiple states and how they do their work. So that was another task, another hurdle that had to be hurdled. We also were able to gather together CAFO data, the concentrated animal feed operations. A lot of people talk about the nutrient loading in the soil, in the waters, in the streams, and these are the NPDES permitted CAFOs at this point, and we're in the process of developing a database of the non-permitted CAFOs. The permits for CAFOs are as you typically need a certain number of animals on your farm to qualify if you're below those limits, and a lot of people play games with keeping below the limits so that they have multiple farms and multiple locations with all below the limits so they can have more animals in total. But these are the permitted ones, and these have to be these have the restrictions of the NPDES permits upon them. But then if you're below that permit level, you do not have those restrictions. So we're in the process of trying to map those out according to what the county wants us to look at. And again, we looked at not just Lucas County. We looked at the entire basin and gathered all this information together, which was not in any one location. So we had to comb through many, many different data sources to try and find all the permitted CAFOs, and that was fun. So it made it an interesting task. And I used everybody asked me, it was hard to find a good animal symbol, so I used a deer. So we're going to change it to a barn, we decided. So. But I like the deer. All right. Water quality sampling locations. We have data from a number of different sources. We have the data from the EPA STORET data set from the Ohio, Indiana, and Michigan, all in this data set. We have university information from Heidelberg, and we're in the process of obtaining other information from other universities that do sampling. We are looking at citizen sampling so long as they have, that's why I asked that question about is the data been QA'd and qualified. That's one of the big hurdles here is if it's not, then making judgments off the data makes it a little tougher when comparing to qualified EPA data versus that's vetted. So we have to be careful about what data we include and make sure that it is all vetted data. And it is scientifically valid data. Not that those aren't, it's just they're not to a certain standard. So we were interested in getting those and putting qualifiers perhaps in there. But that's the beauty of the system that we've built here is we can expand this in any different direction that the county wishes to go to analyze this data. Down the line with further analysis, more data sets that can come into here, and it can be expanded versus a static report. And this can be updated as needed to the citizens of Lucas County and to anybody else. You don't have to be a citizen of Lucas County. You could be a citizen of anywhere and look at this. So it's going to be available to the people. And that's one of the things that we were striving to do with this. Because this is very important to show that, hey, we can put drinking water impairments on this map, which can be temporary, taken off and put on as needed, and the city can post those. So also on the sampling data, we have the actual data within here so that anybody can get in and actually download this information. At least I hope. Whoops. Where'd that one go? Where is it? Oh, it's at the bottom. Yeah, okay, here it is. Where'd it go? Right here. Stop that. There we go. So it pulls it into an Excel table onto your own computer. So if you're looking at your particular stream that you're interested in monitoring, your local stream, or just something you're working on, that data for the nutrients, for the phosphorus and nitrogen can be pulled into an Excel spreadsheet. We've had requests to do mass downloads, but that gets trickier because you're looking at a lot of data. If you're looking at an entire watershed, it's a lot of data. So there are ways to get that. But the problem, one of the things is that when it's the EPA data, you can get it from the EPA site if you inquire mass amounts of data sets, but we have other data sets that are not in the EPA database, which can be pulled off the site. So if you're looking to do analysis, or if you're a part of a watershed group that's trying to get data, this is a good way to do that. And we've reached out to all the different watershed groups in the area up there and gotten their input to see what do you want to see out of these tools. And it's a bit like herding cats, but we got a large percentage of what they were looking for in these data sets. All right. So as you're going through it, you can move right through this, and it gives explanations and web links with more information about understanding what it is that you're looking at. So we want to be this to be a warehouse, a community information dissemination tool, and an educational tool all in one. We also have the EPA combined sewer overflows. So we've got those for Michigan was hard to get a hold of, so we're still wrestling trying to get Michigan's data. But we've got Indiana and Ohio for the combined sewer overflows. Those are the EPA permitted ones, but we have other data in there from the local from Lucas County about their information about unsewered areas and their overflows that they have in their databases that are different from the EPA's. So there's a lot of county by county, city by city. There's information out there. Getting that information is hard. Because you have to go to each county and try and gather that information. Go to each city and try and talk to the right person and find that information. And most of the time, they don't have it in a format that's really accessible. So we're working with the data that's available, but it will continue to grow, especially as people become familiar with this tool, and they will get their data on there, or citizens will demand that their data for their city or their county gets available on here. So I think this is going to be an ever-expanding data set. Walking through it still, public utility infrastructure, we got all the sewer data for wherever there's GIS data on here. We wrestled with the pertinence of the information, but we do have it in there at this point. But some of the data that's available is just is not real pertinent if it's sewered and it's treated, and we have the the treatment plant in there. So is it necessary to have all the lines in there? Well, maybe not, you know. But if we have the ability to put different cities' pertinent data into the system. Critical unsewered areas, walking through, this is from county by county basis, so we can look at different unsewered areas that their Department of Health is looking at, and we can flag those as potential areas that might need improvement. So as the county moves forward, and in individual county, we can actually highlight these areas as targets for improvement projects. We're also able to track down the biosolids sludge field application areas. These are permitted wastewater treatment plant treatment area, places where they can take the waste and basically use it for farming and spread it on the fields. It doesn't mean they have, it's just been approved to do so. But we were looking at, you know, what are the causes of the harmful algal blooms, and it's been already established that it's the nutrients that are in the water system. All right, so nutrients come from point sources, non-point sources. The point sources, which are well documented, really. I mean, as much as the EPA has permitted them, and those are easy to find, and you have them on there. It's the non-point source solutions, non-point source sources for the pollution, and the unpermitted areas that are probably more problematic for the water quality. So one thing that is really prevalent throughout northwestern Ohio is just the sheer quantity of agriculture that's out there. Point sources are definitely a source of nutrients in the water, but more undocumented, I know there's a lot of studies that are being done on this, but is the non-point sources, the runoff from the fields and the biosolids that are put on those fields and manure, and it all flows off. So there's been a lot of back and forth about was the best way to apply these things so that it causes the least amount of impact. And those are ongoing studies. But at the same time, we're going to try and do you know, more investigation into the non-point. All right, we also have land use information in here. There is the National Land Cover land cover data, the National Land Cover data is also in here. This is publicly available data as well. This is the area that we're talking about. The beige color is crops. So I don't think there's a majority there, is it? Do you think maybe? But it's a lot of cropland in that area. I've actually embedded within the watersheds themselves land use information per watershed and per sub-watershed from the down to the HUC 12 level, and across the entire area, it's around 74% of the land area is crop land. So why are they having problems? I don't know. I'm not sure. So this is all in there for anybody to look at. We have at the end links and acknowledgments of where we obtained the data. And at the bottom it ends up going to a link which brings you to the application itself. This is an introduction. This is a report, but it brings you out to the actual application where you can start to look at all the information to do whatever you needed to do. And this is it. I already logged in, so it's already in there. So this is the Western Lake Erie Nutrient Source Inventory, and you can start to look at basically anything in here. So we have information embedded within here about the land use. Like if I go ahead and click on the Auglaize watershed, it gives you an acreage area, the number of HUC 12s within, the number of miles of stream within that HUC 12, HUC 8, the amount of acreage of NWI wetlands in there, and it goes on and on. So we have the square miles of all the different land uses by HUC 8 and soon HUC 12. And then we break it down by percentages across that area. So whoops, I go down here. There's included a bar chart at the bottom where you can actually look at what the cultivated crops are. Auglaize watershed, according to the land use information from the gap analysis, is 80% cultivated crops across that area. There's not a lot of cities in Auglaize, and and they're not all, polluting to the same level, but there are some that are more than others. And pinpointing the problem areas is part of the purpose of this study and the purpose of how they're going to be going into the future, is trying to pinpoint those problem areas or areas where streams that are having more impacts than others, and maybe looking to target restoration projects in those areas, whether it's through that county or that city applying for a grant or funding and moving it into there. One of the things I like to point out to the county is it's not all bad news. Is that when you look at data like this and you're looking at a specific thing for the nutrients within the streams and looking at the harmful algal blooms, it's not all bad news. There's good news out there too. Is some streams do well. Some streams are less impaired. They can use this as a communication tool with the public to highlight those projects that are improving the quality. Any kind of stream restoration or wetlands projects that they might do, or anything to stop some of the wastewater treatment plants from overflowing into the streams, or farm buffers. Projects that they do can be put into the system as well. You can put it in as a point into this thing with a link to the report and photographs of before and after. You name it. It's expandable to anything you need it to do. And it's a great communication tool with the public. And it gets into as much detail as you may need. If some people who are doing watershed groups, this will generally sometimes need more information, but this is a great tool for them to look around and to get information about their particular streams that they're looking at. A lot of times when they do an analysis, they look at a particular HUC 12 or small or a stream, and you can gather all that information off of this. If you need the entire watershed, and you need all the sampling information, well, you're probably going to have to go to the EPA, because that's a big download. That's several gigabytes of information, which is difficult to translate. But you go across, each watershed has its percentage of land use across it on each thing. So developed land, 10%. Cultivated crops, 80%. Undeveloped natural lands, a whopping 6%. So it's wonder what's going on there. So, all right. So from here, we can zoom into anything we need to look at, and we can look at the data in any way that we need to look at. Is this mouse working? Yes, it is. All right. So for example, we can zoom in to a particular area. As you zoom in, different layers will show up, because over the internet, it's difficult to display all the data in GIS at a zoomed out level, and you have to kind of come into it and zoom in to get more refined information at a closer level. So we look at, I like to zoom into Defiance, because it's where 4 HUC 8s come together in one location, and there's a lot going on there. There's a city right there, and they've got their wastewater treatment plants and NPDES permits and sampling data and everything in there. So we have information that anybody can look this up. Whoops, let me use the mouse. For that, so we can look at the STORAD sampling data. Come on, go. There we go. All right. So you want to know what's happening upstream of your town? Here's the here's the Excel spreadsheet. Come on, stop popping up. There we go. And then you can go over to, and you can download that and look at that and continually monitor that for your particular stream if you want to get involved in monitoring your streams. That information's there. There's multiple layers in here to see. You have it kind of cycles through the layers themselves. There's the side-to-side button where you can cycle through all the different layers. And again, for a person who's not familiar with GIS, the video will covers how to use these things. Got the HUC 8 watershed information. You have your study area, and then your HUC 12 is the Flat Rock Creek Auglaize River, and there's its information, which is going to be, I'm in the process of updating that with all the land use information by HUC 12, which is a lot of HUC 12s in there. So additionally, whoops, let me zoom out here. I'm trying to find one here. All right, we got drinking water intakes. We got those. We got all the drinking water intakes that we could find. There's more, I'm sure, that would need to be gotten. It's a permanent, or it's a continual process of updating, and we're going to be periodically updating this information from the county. The county's got us on contract to periodically go in, gather all the sampling data, reload it into the system. So as data becomes, not as it becomes, but like periodically, we'll get it all updated into there, and then it's got the information about the let me see, let me find it. Drinking water intake, store at location, HUC 12. And then we have the land use information. Again, we can, now another nice thing that they can do is they can actually look at the, you can change your view. So we can put the imagery in here as needed and get into that area. Now we have the NWI wetlands in here as well. This is the individual NPDS permit individual station, the outflow area for that particular NPDS permit. It's a facility by apparently Deal Incorporated. I'm not singling them out. That's just where I clicked on it. And you can link right to their permit and go and see what the limits on their permit is. So, applicant for Deal Foods Ingredients Incorporated. So you can get right into each of the information data sets and check it out for yourself. Let me go, oops. All right, you get down here and you got some biosolid fields right in here. You also have a lot of outflows associated with that. Oops, I'm going the wrong way. For example, here we have a live link to the stream flow gauges from the USGS, and that brings us out to that particular station, and you can look at your water flow data for that stream. So you don't have to go out and search for it on the internet. We'll bring you right to it. You can go right to that link, and you can go and download, if you're doing a study of your stream and you're looking at overflows, flooding incidences, which are going to overflow the wastewater treatment plants, and you're looking at surges in bacteria or nutrients going down from the stream, you can compare that to your rainfall data and your stream monitoring data right in this. How am I doing on time? Am I over? Am I good? All right, cool. All right, so allowing people to see this information is very key. Let me go back out to topographic. But this gives you a good view. Whoops, I'm not too far. Good view of how much information is out there. Like I said, that's daunting, to an average person who doesn't do environmental analysis for a living. All right, it's daunting to everybody. It's just a lot of. It looks like it's got the measles, but it's got. It's going to be useful to everybody who needs to be looking at information, or is curious, or wants to show improvement. All right, you have. There's sampling data, and if you have upgraded your wastewater treatment ponds for your area, and have gone through a grant to get that information, and gotten improvements on your water quality or your outflow from your farm, that'll show up probably, in the water quality data, and that'll show up in the system when it's updated. So that's something that people can show as the positive, as well as where the impairments are and how negative things are. But you can bring this to everybody and try, and it's a good communication tool to get stakeholders on board with understanding the problems with the water quality. I think everybody in Northwest Ohio, regardless of whether you're what would be a culprit of polluting the water system, everybody understands at this point up there that there's problems with the water. And I think most people don't want to really pollute their water system. So getting them on board with this is a good tool for helping everybody understand what's happening to their water system in Northwest Ohio. Additionally, this can be applied across anywhere in the United States. So we have, there's varying amounts of data. Of course, there's some places have better data sets than others. For example, we were able to get the CAFO information for Indiana and Ohio, but we weren't able to get it from Michigan. Certain things, just getting the right agency and the right people to get you that information. They're very tight-lipped about that because there are stakeholders involved in there. There's the farming industry, there's the animal production industry. So a lot of times they may not want that information out there, or that might be a good thing to have it out there so that they can show that they are trying to help. Either way, I think it's a great way to engage people. But again, we have the individual permitted CAFOs in there. We have, like for example, and I'm sure they're very nice people, James and Rosa Langacher. I think that's how you say it. I don't know. But they have their information in there that's included with the permit. It's a concentrated feed operation. And then you could see, what do they have? They have 53,000 broilers, which are chicken farm. So Northwest Ohio's got a lot of chicken farms. And there's a lot of pig farms, but there's a lot of chicken farms too. I used to go to a Frisbee tournament called Poultry Days because it was so prevalent. There's so much chicken over there. There's a festival, a poultry festival, and it's good too, boy, it's really delicious. But they have a lot of chicken over there and a lot of chicken waste. So it's important so we can see what they're doing at that particular location. There's 53,000 broilers. I didn't know what a finisher was either. I had to learn what a finisher was. It's a pig. So, all right, and that's basically the system, and how what we're doing for them, and how we're trying to engage the community in taking a stakehold in their water quality and taking an interest in their water quality and understanding their water quality. And this is also going into the future of this project is going to be, we're looking at the University of Michigan has run watershed models for this area. We're going to be taking some of this information and talking to them and maybe updating that model and putting in more information than they originally had with that to run the model. We talked about the county wants us to, the results that we get out of that model, we want to be able to spatially enable that information and get some of that modeling information into here. Down the line, that's where we're going with this. And the county is very on board with this. For a fraction of the cost that it costs to upgrade the drinking water treatment facilities. So across the board, yeah, it's probably going to cost a lot of money to enact a lot of projects, and it's going to take decades of work to get enough water quality improvements to make a change. That's just the nature of that much area, that many farms, that many wastewater treatment plants, and that many people. But ultimately, we want to try and get it down to a certain level, and the county is very much on board with making that happen, and using this as an information and dissemination tool. That's about it, right there. Any questions?
Did you say this is already live on the Lucas County website, or not quite yet?
Not yet. We're in the process of transferring it over. By the beginning of the year, it will be.
Okay.
Yeah. Yeah. Yes.
The date on here, maybe you said this, I'm sorry, you did. The date on here is updated how long?
We haven't figured out the term yet on that. It's about to go live on their website, and then we're talking at least 2 times a year of updating all the information that's on there. They don't sample every stream every year or every station every month or so. There's a sampling protocol that's on different streams, so not all of them are updated all the time. But it just depends on how often the need is and how much they want us to update it. But we're looking at twice a year right now.
And then also the water quality information, is it just like the state data, or is it also like Heidelberg?
It's Heidelberg as well, and we've been able to get going to get data from the University of Toledo and a couple other places. It's a work in progress because you have to get that data. That's the problem, is getting the right person to give you the data. And part of this is putting this out there so that places like the different universities and different community sampling or places will want to see their data in here and say, hey, ours is in there. We can see it. That's our data, and that's something they can take ownership of. And we think that's something that'll grow over time. So another one. Oh, right there, yes.
You kind of crossed it. It's just so much. I just think it's huge to keep it updated.
It is.
And how many people do you have on your team to keep this ongoing and to keep it updated?
Not as much as you think.
Okay.
All right. So
It just seems huge to me.
this is really the effort of 4 people. So I did all the data crunching and getting all the GIS data into this system. I had Mia, my colleague here, help me with gathering some of this data. We had another person out of our Toledo office getting all the NPDS data, and another person there trying to gather all the CAFO information and we started to call all the different counties and cities and realized that's going to be, we have a certain budget to do this, which was not exorbitant compared to the upgrades to the water treatment plant. I mean, this is we did this for about $60,000 total. So it's not a lot of investment. It's area dependent as well. The larger your area, the more data there is, the more time it takes to crunch all this information. So it's not as much as you think, but if you know, like I said, if you know what you're doing, you can kind of get right to the answers, and we've worked out ahead of time what did they want to see. So okay, well, we got the information that they want to see. There's much more information to be put in here. I have the fish and invertebrate sampling from Heidelberg in here, but we don't have all the EPA fish and invertebrate sampling for all the different water quality data, because we determined that a lot of that's not pertinent necessarily to the quality of what the cause. That's a result, and we were talking about putting that data in here down the line. But we have that. It's there. It's just a matter of manipulating it, getting it to display spatially, and linking the data up to those tables, like I just showed when I downloaded the tables. So that data's out there. We're able to get it into the system as needed, and not for that much money and not time. Yes.
How long is it taking you to get to this point?
This point, well, let's see. I would say about in total like if there's a lot of, like I said, getting everybody all on the same page is like herding cats. All right, all those different watershed groups, citizen action groups, the county, the city. That's where most of the time is taken up. Crunching all the data. If you were to boil it down, probably about 3-4 months. If we were just given a mandate, gather all this data and put it in the system, we could do it in 3 months, 4 months.
How long have you been doing
This has been going on since probably last January. Yeah. Yeah. So it's there. I know we've presented this to the deputy director of the EPA and to the head of the Surface Water Division. They were very impressed with it, and they were very impressed with the fact that we have multi-state data, and they really liked it. I mean, they had their comments, of course, which were very valid, and but at the same time, the county doesn't want to wait for others to take action, so that they've gone ahead and starting to take action. Any other questions?
I just have a comment.
Oh, yeah.
We do watershed planning here at Eastgate, so we also gather a lot of that same information that you do, but just a much smaller scale. So I know how much work went into it. But I wanted to say I love this format because at the end of our watershed planning, we have a stack of papers, reports, and maps, and it is intimidating to the average citizen to go through that and to understand it.
Yes, it
so
is.
I love that, and I can hear our environmental managers here, and I can hear her wheels turning up here. It's
Yeah.
great, thank you.
It definitely it starts from the simple and goes to the complex. That was kind of the plan, was introduction to here's your watershed, here's your streams, here's your drinking water, this is what you have out there. And then as they get more interested, it sucks them in. It's like, okay, what are these dots? My stream right by my house. That's one of the things that, or the watershed group goes, oh, okay, well, our data's not in there, or I don't have that data, or I didn't realize that was there. And that's, a lot of it, there's a lot of restrictions for people looking at data and information. One of the largest restrictions is understanding and know-how. Getting to that information, wading through all the different websites that you got to go to, calling the people. most people don't have the time for that, because unless you're retired, which I would love to do. I'll die in front of my computer, by the way. So we have, there's a lot of problems with spatial data. Accessing, GIS software is not cheap. So people don't have the ability to look at this in a map like I do. And when you have the GIS at your fingertips to do all these kinds of analysis with, and this is just the tip of the iceberg of what analysis you can do with GIS, and then even incorporating the modeling information, which can be most modeling information is the front end of most models is GIS spatial data, and the back end is spatial GIS data. Comes out. It's data in a place representing something that's happening there. So it all ties into GIS. So that's not cheap, and that's the problem, and that's what's been a big boon with the ArcGIS Online, has been allowing people to display information to anyone, and they can all they need is a web browser to try and look at it. So it's very, very revolutionary in bringing information out to everybody. Yes?
Thanks, Dr. Mom. And Bethany, Justin Wandop and I, we've had conversations with Youngstown State University and Friends of Mahoning River Sentinel group that goes out and monitors certain sites along the Mahoning River, and we've had conversations about creating such a map for our local Puck 12 watershed, so on a smaller scale rather than going the gigantic Mahoning River scale. Right. And just mapping out the information data that we've gotten through our watershed planning from the Ohio EPA and our close relationship with the Surface Water District, and then also with the volunteer groups, as well as what Youngstown State has done monitoring. But again, it's kind of, if we don't know what's going on, then we don't know the data that's out there.
Exactly.
And, whether or not the data is credible, entered into the Ohio EPA's database isn't so much of a concern for us here at Eastgate. It's more of when we're doing the watershed plans and we get the data and we create these maps, it kind of targets hotspots for implementation. So
it really does.
That's more what we're looking at on a regional level for planning here, as far as where do we see the problems are, what watershed is it, and it identifies who the stakeholders would be.
Yep. That's the same thing Lucas County is talking about doing, the very exact same thing. TMACOG, which is the regional government organization up in Northwest Ohio, is also on board with this. If you notice at the beginning, their logo's on there as well. And they've kicked in some funding for this. The county's kicked in funding, and the city's kicked in funding for this. So that's exactly the idea. And we talked about also including the certified, quality assured data, but just put a caveat associated with it. This is from such and such. It's not up to the standards of the EPA, but it's information. It's out there, and it's probably coincides with whatever the EPA is finding, probably.
Right, and just to be the boots on the ground, since the EPA can't be everywhere every single moment of the year because they have their schedule that they have to run. At least those of us that are certified can be there to go through the measures and get the quality information.
That's right.
But do you have has anything been implemented so far as like projects wise based on the data that you're providing?
Not based on this so far. It's independent so far, but we talked anything that's water quality improvement so far has just been independent of this particular thing. The large, but that's where they want to go. After talking to them, I was able to convince them that if there are water quality improvements, I was talking to somebody at the Corps of Engineers, which any kind of water quality improvement project that's going to happen in our streams has got to run through a Corps permit of some sort, right? And they have that information, but they don't have any way of disseminating it. Especially, if it's private, then you got to be careful. But if it's a public land, that can be also incorporated into this. So, being that this is just the data gathering stage, and the next stage we're looking at doing some analysis, GIS analysis, and looking for potential areas of improvement, like you were talking about, and then from there it's going to go. But it's a large area, and also you're talking, multiple county governments and city governments in multiple states as well. So it makes it a little tough, but yeah, it's, they're moving forward.
Thank you.
Thank you very much. Just shut these.
You want to take a 5-minute break, or we? Okay, 5-minute break, and stretch your legs, and we'll get the next presenter ready.
all
But
along.
you have to show the point source.
Is the mic still on?
If you're looking at the imagery like that, you can actually pair that. Yes, I do.
We're a little bit behind schedule, so we're going to get started with our third presenter. If you could find your seats. Thank you.
Ready?
Here's the clicker.
Okay. I think some people are still awake. Well, good afternoon. My name is Rafat Ansari, and I have a confession to make. As Daphne pointed out, first of all, thank you for inviting me here today. That I am the least knowledgeable about talking about HABs. If I have thought that a couple of years ago, if I ever give a talk on harmful algae, I wouldn't believe it myself. But Earth is still a planet. Yeah, NASA, does a lot of planets that we see. However, this particular talk that I'm giving to you today is on a very personal basis. So 2011, there was a Algal boom. I have no idea what that is. But my wife and I were flying from Chicago to Cleveland in my airplane. And then she started looking as soon as we crossed into Maumee River along the shoreline coming towards Cleveland. We pointed out that the water down below looks very dirty, looks like green. And when I looked down below, it almost felt like somebody put a green ink on it, of green color. It was really bad. But didn't pay much attention. We stopped, parked the plane, and we went for lunch at a Mexican restaurant, which is by the beach in Lorraine County. And it was awful smelly. It was not very good sight. And there was a sign on the beach which says the beach is closed, do not go in water. So fast forward now to 2013. I was invited to give a talk on a totally different subject, because I do experimental ophthalmology and biomedical engineering. And most of the work I do is about astronaut health. So think about going to the HABs. We went over there, give a talk, and there was one guy from NASA, his name is Larry Leo, and he talked about hyperspectral imaging, looking at harmful algal blooms for high-flying airplanes. When I look at that, I said, gee, I have seen this for my airplane. If there is anything that we can do differently, very low cost and effective. And so Larry invited me to go to a couple of conferences in Michigan in 2014, early on in February. And that's how this whole project started. Okay? So that's how my background. So if I say anything not correct, please forgive me for that. I'm not really, so that's why I'm not really expressing NASA's viewpoint here. That's only on mine. Okay. So the goal of this project was to help develop an early warning system to alert the communities which live along the coastlines, not just here in Ohio. You will notice it that I will only focus my talk on Ohio, but this has now been expanded to all over the country, throughout the United States, okay? And next year we are expanding this to Alaska and Northwest United States as well, okay? So the whole idea here is to provide near real-time data. Okay, and the previous speaker, I think Mandy, has spoken about the satellite, how there are gaps in the images, they are not available right immediately available. So this, we could do that and also provide this free of charge. Okay, so no money involved in there for anybody who's interested in water quality monitoring. So again, as I said, looks like the water quality is everybody's business. Okay, it's our personal business because of course we cannot survive without good quality water. And this was I reading in the this survey, which is done by the Earth Science Decadal Survey, that HAB problems is the worldwide ecological problem. And here in the U.S., as you all know better than I do, that almost every state in the United States is affected by HABs. So these are some of the remote sensing monitoring methods. The satellites, you have heard about it, from Mandy's talk. High altitude flying, which are doing some of the work with the hyperspectral imaging, and now big tail about the UAVs, okay, or the drones, okay, and the boats, and now we are exploring can we use general aviation, okay, from the interest that I had. But none of the methods that are described over here is sufficient to really use it for actually what we like to understand about HABs. So they all have good things, pros and cons, okay, bad things associated with it. And I think some of the things about satellites are that if there are clouds that we heard before, then the images are masked. You don't get that information. Immediately, the data is not available. There is always a gap, about 2-3 days, from say MODIS satellite or the NOAA HABs bulletin which come out of it. UAVs have a problem because they are restricted by FAA. These are only line of sight measurements. So if your remote control doesn't work for about 1 or 2 kilometers, it can fly away. I had a friend of mine who was flying this and he crashed into 7-Eleven in Lorain County. Yeah. So the boats are very nice, but government scientists or the people who are working for EPA, NOAA and other people, they cannot be there everywhere. Okay, so there are only few measurements and few places you can select of that. So this is where we thought that maybe we can use general aviation airplanes to see what we can get out of it. Okay. So obviously there are 600,000 pilots in the United States and about 200,000 general aviation aircrafts, small aircrafts. The picture above there is a photo from Oshkosh, the Experimental Aircraft Association picture. And in that photograph, you will see about 15,000 airplanes, okay, only in one single place in the month of August, July or August in 2014, that picture came from. So if we can use a fraction of these people, okay, to use that as a source of taking pictures, photographs, we could perhaps learn something from there. So the effort here is completely volunteer, okay. NASA does not pay for anything that you will see here, okay? None of the pilots are paid by NASA or they're directed by NASA, not guided by NASA. Each pilot is fully responsible for the safe operation of the aircraft following the FAA regulations, and they are also free to choose their own flight paths and flight plans. And so we are completely volunteers on that basis. Everybody is doing very free work. And if there is any pilot in the audience, any pilots over here? No? So if any pilots, they normally contact the FAA before mounting the cameras, but this is the memo that FAA has. We tell them to follow that. So the approach is that the pilots capture high-resolution aerial images and also videos in RGB and near infrared. Okay, so these are very simple effort. This is not to be confused with any advanced imaging using hyperspectral imaging, and I'm going to come to that in a second. Flying at about 3,000 feet above the ground level, or about say 4,000 MSL, which has very good spatial and temporal resolution over other assets, which include the satellites and includes the drones and other things. So the pilots are supposed to transfer the post-flight images so data can be publicly available to students, teachers, and researchers, or anybody who really cares to look at them. And our pilot network, which started with about, say, 2-3 pilots, have grown now this year to about 100 pilots. So about 100 pilots offered their help, and few, even from Australia, Greece, Israel, and Ireland, also volunteer to do this work. But given the enormity of data, and as we have seen in the previous talk, I mean, this amazing amount of work that you need to do. So we only use Ohio, Michigan, Minnesota, California, Texas, and Georgia up until now. Okay? And my focus is going to be in Ohio because we are all talking about Ohio watershed here. So here is the image quality that you can see. And if you look at this image quality, you can see this is the picture of the Kelly's Island in Lake Erie, Ohio, as you perhaps know. And I'm flying here at about 3,000 feet, and the photograph shows very lovely, this is stream that's coming in over here. Okay, you can see particulate matter. Okay, that is hard to see from the satellite images. Okay, that you can see so small there. So this is one of the qualities. And then the flight cost for a single engine airplane is about $60 for about 200-mile coverage. Okay, and you're going to see our flight tracks. I will show you that. So another resolution here picture that you see in this photograph on the left is taken on 18th of July 2014, and then compare that on the picture on the right, which is 25th, a week later, and you can see this is clear beach right over here, and then you can see volleyball nets on that side. Okay, some people decided to play volleyball in the summer, so that's what you are seeing over this area right over here. Okay, so this resolution really excited me to look more into these things. So this year we came up with this camera, which is from Garmin. Okay, right here. It's a very small camera, about 3 ounce. It has GPS built into it. Okay, so the georeferencing is very easy, or geolocation is very easy. You can control these cameras by your iPad or cell phone from inside the airplane. And then we use 3 cameras. So in fact, we don't have to use all 3, but we use in this case just to see the proof of concept. So the 2 cameras are put in the nadir position, looking exactly directly below about 90 degrees from the airplane. And so 2 on the left wing and 1 on the right wing, and 1 is looking in the forward direction. So you're looking at a very nice view of the entire area that you're seeing, and that was a video. So 1 is video and 2 are the RGB and NIR camera. So what is the resolution here? So this is this year in September, 21st of September, Joe Ortiz, who is a professor over at Kent State University. So he asked me to fly over, and what you see here is this is his boat, Joe Ortiz in his boat, and he's pulling this mirror array. This is the mirror array right over here. And this is a 4-foot by 4-foot mirror array right here. And the resolution of this image, and right over here is his boat. I think you can see that right over here. So that's the boat. So this resolution is about 1.3 feet, okay, per pixel. Okay, so a very high resolution picture that you can get. So as I said, we had RGB camera, and we have near infrared camera, which modified that, and then the video, look here. So if you are interested to see the video, you can go on this website on the YouTube, and you can watch a 2.5-minute sample video. That's what it looks like. So it gives the viewer a perspective of what area that you can really see it. And then you can, I will show you where you can see these images. And if you're looking at this image right over here, this is near Huron River, and this is the golf course right here. And the golf course is really exaggerated in the near infrared image right over here, as you can see in this image right there. Okay. So this is the typical track for Lake Erie, in western Lake Erie. And here we are starting in Cleveland and going all the way towards Detroit, Monroe, Michigan right here. And here is the islands. And each pin that you can see right over here, each pin is taken at 5 seconds. So this is an image. Every 5 seconds we are taking images for about outbound and inbound, which is over 200 miles area right over here. Okay. So if you can, and you can see this at the bottom website right over here, these flight tracks. So this year we have got 300 gig of images, 300 gigabyte of images over western Lake Erie alone, and they are all listed in about 25 flights this summer in 2016. So this is very nicely, because the technology is there now, and you can just take these images, and this is very accurate georeference or geolocation that you can do, which can act as an early warning system. So here are the images. Every 5 seconds, these images, each frame here are about 50 images in there. So you say, okay, where I'm living, say in this area or interested in this area, you can click on this, and you can get the file name, you can get the coordinate information, and the date, and the image is displayed right over here. So people can see where they are and what exactly they are looking. So the CSU, the Cleveland State University website, Professor Pete Clatham's website, he is archiving these photographs. And on his website over here, this is the grid. And the grid is again this coordinate, the longitude, latitude information right here, every grid. And then if you can go and click any of these images, the grid, then it will show you those images. For example, there's a Portage River outflow. This picture was taken after a rain event that you can see how the plume is coming into the water. And so far, we have the data from western Lake Erie, upper Mississippi River in Minnesota, Lake Sidney Lanier in Georgia, and Texas, Lake Travis, and Lake Cunningham in California. So in California this year, the HABs problem was quite significant. Okay, in our area was not as bad as 2014 or 15. Okay, but so those are the images that you can see from there. So here are some typical examples of data. As the time goes on, we are looking at the changes in water quality. Okay, so here is a picture of Western Basin, July 5th, 2014. Okay,
Can
so
you
some
turn the lights out? Would it make it easier to see?
How is it?
Just to the front line.
Okay, all right, sure.
It said something.
Okay, so some people are really enjoying the recreation here, the boats and stuff you can see, and not much of a problem right now. The water is kind of grayish looking, which is the case mostly in Lake Erie. And here is July 18th, and you can see all this scum floating. Okay, so this is again the picture is showing very nicely that how that these are the trails from the boats that running over here. You can see that. Okay, so that's July 18th, and then if you look at July 22, okay, and 4 days later it is kind of dissipating, but it still is right around in this area here. And then if you take another photograph of July 25th, a week later, and it has quite a much of dissipated, but it has moved towards the west and a little bit towards the north. Okay. And this is where we thought, in fact, that it might, create some problems later on, and that exactly what happened in August, in the beginning of August. So this is the photograph we took on August 4th, flying over the Toledo water processing plant right over here. So the middle here is the water processing plant, and you can see it was completely overwhelmed by the HABs. And that exactly what we made the news on CNN and other places. Not too good, but that was the news, and I think someone talked about that previously. So what these pictures have shown us that the HABs is a complex phenomena. It's a very dynamic system. It has several orders of magnitude from very, very small areas to can affect to large areas. And timing is really everything. It can take any hours and days and weeks to develop, or so it could be as fast as you would like to look at it, and that's where the gaps are in the system. So for example, in this slide here, this is the experimental Lake Erie harmful algal bloom bulletin number 22. And if you can see here, this picture, this was taken on July 17th, okay, at 2:15 p.m. But the data was not available in 22 of July. So this is always, there's a lot of gap, about 3 to 5 days gap. And this our photograph was taken here, and spatial resolution here is less than 1 meter, and the time lag essentially is none to very little that you can see these pictures. So those are the advantage of aerial imaging. And again, as I said before, these areas, again, there was a HAB event here 12 miles east of Toledo, but none of the photograph in the satellite or high-flying aircraft can show that. So the satellite limitations are shown in this paper right over here and in the decadal survey. So the physical and biological factors affecting bloom dimensions are critical because the resolution of patches is smaller than 5 to 10 kilometers squared is generally not possible with current satellite technology, and that's why few management decisions rely on satellite-derived water quality products. Okay, so these are some of the major limitations. So what can we learn from this general aviation, citizen science, aerial images? So someone has already talked about, I think Mandy talked about that the satellite identifies change in color by spectral analyses, and it quantifies the concentration via validated algorithms. Now that is not easy. When you talk about algorithms and validation, it takes a lot of work, and there also is not accurate. It has a lot of errors involved in those type of analyses. So what it does really is look at chlorophyll A, suspended particulate matter, turbidity or reflectance of light or clarity, color dissolve or CDOM. So this is what it does. There was high hopes about doing hyperspectral imaging, as we all know. And Maris, satellite, which was doing some work, but it is not operational anymore. It died in 2012. And HICO, which is also a very big deal, and HICO also died in 2014 after a solar storm hit it, and so it is not operational anymore. So what a human eye can really do, if we can take a look at the human eye. Again, my background in the ophthalmology. So when you look at this, then chlorophyll A can be identified by green water, which could be present for algae, and suspended particulate matter could give a brown color water, and turbidity could be cloudiness or haziness, as we can see it, and the sea dome could be identified as tea-colored water. Okay, and that's what we really, as pilots, we can look into those type of things. So here is a photograph, both in the RGB and the NIR, the near infrared. So both cameras that we use, that I mentioned about Garmin XE cameras, so I modified the same exact identical camera by taking out the red filter out and putting the Roscoe 2007 filter in the front, and that makes it a near infrared full spectrum camera. Okay, so here you can see, look at these pools here, okay, in the blue, and look at these pools in the blue right over here. So it's very much exaggerated. The water here, you can see sedimentation layers right over here on this side, and the water in purple gives the in the near infrared image right over here, and you can see a lot of different type of features in these two images. So here is one interesting image. So I took this image over Sandusky Bay right here. This is in the RGB, and this is in the near infrared. And when you look at this, the streaks coming out of it, right here is white, and then it is very much purple or reddish in color. And that's perhaps because of the algae being stirred by the engines which is running the propellers, and that's what is showing in the water. So it becomes, I think, it has become very useful to see, perhaps chlorophyll-rich water from these images here. So now the scientists can say, well, we would like to get more information. Okay. Now someone mentioned about ArcGIS, program, and these are very expensive, and we don't have any the availability, anything available for us to do that. So we try to look at, what is free software that is available out there that we can really use. So here is one of them is called the NIH ImageJ analysis. Okay, has anybody uses that ImageJ? No. So ImageJ is a free analysis which was really done for analyzing medical images like MRI images and those type of things, for looking at better contrast sensitivity in these type of images. So I thought we can use these, so I provided these to one of my students, okay, and asked him to do some analysis on that. I'm going to show you that. And then the CDAS program, which has been developed by NASA, and this is for the ocean color analysis, okay, using the satellite data. Okay, maybe we can use that, and that is the work that Joe Ortiz is doing. So we can get NDVI and NDWI. We have heard about that in the first talk. And you can get pigment concentration, vegetation fraction, water polarity, and perhaps cyanobacteria and algae. But I must have to point out that none of this represent absolute values, by the way. Okay, they are different from one location to other, which is also true for satellites. Okay, so those are the limitations. Okay, we have seen this different type of a figure in Mandy's talk. Okay, we showed this NDVI calculation, so I'm not going to go in there. Looks like everyone knows about what it gives you, the vegetation and health of the plants. So this is the ImageJ analysis. This is the event on 11th of July this year, and you can see this material right over here. So this is the floating stump in western Lake Erie right over here. So Peter Sankovic, who was my student in summer, so he analyzed these images and looking at different areas in the same image, and looking at these histograms and really finding out the intensities in the RGB images about what would it look like, okay, in terms of intensity of the bloom area or the clear water area, or also looking at this. So this picture, as you can see, have a lot of light in there. Okay, so normally this will not be very useful if you are trying to do analysis in the regular satellite type of images. Okay, so a lot of glint and glare in there. But we were able to at least identify in this area and then compare it with some of the images from the satellites to show that what we can learn. So there is some value to this ImageJ analysis in there to look. And this is what we learned from a fellow named Dr. Chris Fasty. And I was talking to him and sent him these images. So this is the image of the Huron River harbor right over here. And here is a ship docked in there. You can see that in the Huron River. And this is the cement factory, okay, in the Huron River right here. And right on the top here, this is the mountain of the cement, I think, is putting on the whatever they made off. And this is the near infrared image right here. And then he fed this into this ImageJ which also use some type of a Fiji plugin that he called, and he can look at the chlorophyll from these images. And again, this is like from -1 to +1, the health of the plants. So you're seeing this type of NDVI information from there. So what I think it's happening is that we can really give these images to citizens as well, or students, and they can perhaps learn and do some analyses in their areas to see what they can see from these. So this is something new, and CDAS program, which was written, the algorithm by NASA, okay, has never been used for these type of aerial images. Okay, they have been designed for satellite imaging. So Professor Ortiz at Kent State University is now using these. So here is the raw RGB image. By the way, this work is still ongoing. Okay, that's what's going on right now. So here is the Old Woman Creek, which is the station for ODNR, Ohio Department of Natural Resources. And you can see it is really a very nice model to do this thing, because it has sedimentation, it has some type of things are happening by the shoreline here, and then you can see so many different type of plants and vegetation in this area right over here in this creek. Okay, so here what he did is that he used in the CDAS, or for the satellite imaging, what is called as the PRI, which is the index for light use efficiency, which is used for identifying different type of pigments. So he called it MPRI because it's kind of a modified the index for these aerial images. And this is the M very green, which is for plant vegetation. And on this scale here, which shows the relative scale, which can show different type of false color images. So here is the water looks like this way here. And then what are the how much light is being used by the absorbed or reflected from these different type of moieties in this water or the plant vegetation. And this is again the plant vegetation index over here. So for the near images, and we can do both, take co-location near images as well as the RGB and get the NDVI information as normally is done. But now we are learning that we can use individuals as well, and you can do the similar things with it. So he took this aerial image right here, the near infrared, and you can see this, the same Old Woman Creek image for comparison. And now he called this as NDRB, which is the normalized RB image here. And this is to differentiate primary and accessory pigments in this area here. And this is the NDWI, okay, to differentiate land over water in this image here. And this is the green NDVI to look at chlorophyll A variations in different color here. So this is still a very fresh ongoing work here. So in summary, what we can show that we have, I think, the potential of our effort to help science community obtain first look qualitative and perhaps semi-quantitative information on NDVI, NDWI, pigment concentration, vegetation fraction, water quality, and possibly cyanobacteria and algae. And this may provide scientists one more very low-cost complementary tool to assist in the HAB monitoring in their areas of interest. Okay. So in conclusion, I would propose that the GA, General Aviation Pilot Warranty, as I think we've shown that the citizen scientists can be vitally important in the effort to monitor and maintain water quality standards. And we can demonstrate that an early warning system to alert communities is possible via an aerial network. And the near real-time data access is also possible to anyone free of charge, as we have shown now, that can use open source software so everybody can make use of it. So we got a lot of accolades this year from different news outlets and internet people that wrote articles on that. So very happy, but this is not the end of the story. We have a lot of work still needs to be done. So if you have more information, you can feel free to log in to our website right here. This is the data archive website at is a private website that we are developing. In fact, my friend who is a volunteer who works for Ford Motor Company, he is developing this. His name is Sumit Sengupta. And data archive at CSU, this is the website. And obviously, this is the NOAA website for information on HABs. So if you have anything that we can answer your questions, you can write to us or feel free. This is my young friend Terry Schubert. Terry Schubert and I became very good friends because of flying. And he and I started doing these things in 2014. That's my airplane, that's Terry's airplane there, that's Terry's, contact information. And if there are pilots, we refer to Terry, and Terry gives them a lot of information. And that's my information down over here. Okay, and I would like to acknowledge a lot of people. I think the unsung heroes really in this thing is who do not get paid to do this work are those pilots, really wonderful, wonderful people. And this is one thing amazing about United States, about America, and about the pilots. Okay, these are the people that you will notice come from all kind of backgrounds. Okay, some of them are very old people still. Okay, they have come from police officers and scientists. In fact, the one who is flying over in California was the director at NASA. Okay, now he's flying his airplane in that water system there. And then we have Army people, Air Force retired people, some young folks who are just finished their pilot license and those type of things. So it is absolutely amazing to see how much committed these folks really are. Peter, as I said, was a student from Cleveland State University, and Sumit Sengupta is an IT volunteer who is developing the website, and Joseph Ortiz, professor at KSU, and Pete Clapham, professor at CSU. And Leon Guile is my colleague at NASA Ames Research Center, and he is also using some of the hyperspectral analyses from the high altitude flying aircraft to compare with the data that we have, or the pilot Keith Dismuke has taken in California, or is doing some missions over there. And that is the area in California which is really was very significant this September over at the West Coast. And then I also like to acknowledge the NASA's Office of Chief Scientists who have been supporting some of this work that I work under with. So that is one thing. Now, I would, if you give me another just 2 minutes, if possible, I would like to show to the audience here, because I think I saw Mandy brought very, very nice instrumentation. So I just want to show you some of the things that we have done. So I give this project to a couple of my students to develop a little rover. He assembled this little rover, which is where we did the image analysis. We flew over the Lake Erie, and then we took this rover, and the ODNR was so amazing to give us access to their boat. This is the ODNR boat, and we took it over there several times this past summer. And here is the submersible rover. And it has several sensors on board that we can use, oxygen, pH, turbidity, and those type of things. It's very low cost, less than about $1,000, okay? And here is what it looks like. Okay, some of the sensors, or these are optical sensors right over here for conductivity measurements. And over here is one of the optical sensors for light attenuation. And this is very easy to use. And this is the ODNR boat, their GIS system. We asked these folks to take us, where we took the pictures from just about a few hours before, and they took us there. And this also have a onboard underwater camera. And from this underwater camera right here, you can see this is in Lorraine County in the lake, and you can see the floor. And here is the colony in the Kelly's Island of invasive quagga and zebra mussels right here. And you can see this algae mat looking down on the floor of this picture here. Okay. And a couple of very quick things is that this one here in this picture, this is I think the western side of the Sandusky, and this is that park over here, the Cedar Point. And here, when I took these images right here, and then we sent it to folks to take water samples, and they found the harmful plantothrix in this site here. And that was kind of a surprise for some of the folks who work in this area, that how did it get there. Okay. The other thing I noticed on this image here is that, look at this streaks over here. Okay. And this is something, this is in the North Bass Island, right over here. And had no idea when I was flying over, I thought that maybe these things that you look here is because of boats. The boat must have passed here, but there were no boats at all. I haven't seen for miles and miles on that day, no boats. So I showed it to Terry Schubert, my friend, and he flew it over as well. And then he confirmed that there are no boats. I said, well, what is it? So we took the ODNR boat and went into this water, and Joe Ortiz told me that this is Langmuir circulation, this is foam, okay? So we went over there and we looked at it. There was all foam material there. We collected the water from there, and that was also very rich into this. This almost look like scintillations that you can see from here. And this is the kind of some plantotrix he found on the doing the image analysis on the microscope. Okay, so couple things that you mentioned about the nutrient loading in your talk, okay, Dean. And this is something that these are some of the images, videos. And in this video you can see this is the rain event right over here, and this is Lake Huron. And Huron River is flowing. And this is a video, you can watch this on our website, okay, with a voice, and then you can see that how it is moving. And this is a very nice plume you can see here, and a differentiated color at the bottom there. And that really the beginning of these things to the real HAB event later on in the year. This is another one that we saw, and I have no idea what this here is. Okay, you can see that. It's almost okay. So this is in Marblehead area over here. Okay. So some of these features that one can see can be taken and used for these type of images right here. Okay, so I think I'm going to stop here and take any questions that you might have.
I have a question.
Yes.
Well, first, that's a great resource for Lake Erie. There's so much you can do with those images. But I was wondering if the pilots fly on any certain regularity, or if just whenever they happen to go out.
So obviously we cannot ask these pilots, but they're volunteers, okay, that you fly at this time or you fly this time of period. But so far our experience is that if you ask them, okay, that we would like to see this, they normally do it. Okay. Again, one of these other problem is about the weather, because normally we do not fly in rainy weather or in bad weather. So these are normally VFR flights. These are not under IFR conditions. Okay, so that is one thing. But in that sense, the satellite imaging in ours is the same way.
Right.
You cannot see anything. The advantage here is that if it's a cloudy day, that's not a problem because we fly below clouds, so the pictures are probably different. So yes, so we can request to the pilots, okay, that you have a place which is, so for example, say in Youngstown, in this area, and you would like to do it. There is an airport very close by. There are two of them. The one is in Lansdowne, and the other one is the YAG, I believe, here. So there are a lot of airplanes here as well. I think we can perhaps ask somebody to get for some flights. And that's exactly what we did. So first thing I did was that I contacted EPA. Okay, and then the EPA, by the way, was wonderful. Okay, NOAA was wonderful. Okay, when I talked to these folks. EPA headquarters, okay, and this lady, director for the HABs program there, she was so wonderful, and she said, well, this is great, and then she put me in touch with other people, asked me to give a seminar, which we did with EPA and other centers of EPA, different regions attended that. And they identified some of the lakes. For example, in Georgia, Lake Lanier, I have no idea that there is a lake in Georgia. They said, well, our focus is on clean drinking water, so could we do this area here? So they asked some pilots over there to look at these images. And I found a colleague of mine in Georgia, which was amazing. He is an ophthalmologist as well. So he connected that. He has an airplane, so he started flying there too. Yes?
Every one of these pilots has the same Garmin camera as you?
Good question. Indeed, yes. So what we started to do with that, so most of the people, as you know, have GoPro cameras. Okay. The GoPro camera's resolution is very good as well. So some of the earlier images that I had was GoPro cameras. So this is the problem with the GoPro. Okay, so there is no problem as long as images are concerned. They are very high resolution images. The problem is that when I started doing this work, then we have to take the images. It has no GPS on board that camera. So the student has to go and into, say, the Google Earth and match those images with the GPS data that I had on the airplane and combine that with these images into Google Earth, which was very labor intensive. Okay, but that's what the students really do. So we did it, but it was really not easy. It was labor intensive. So in 2016, January, I got this one, and that's when we started asking the pilots to do this. So this Garmin also have an app. It's called the Garmin Verb app, Garmin Basecamp. So if you look at Garmin Basecamp, it is very similar to what you presented in that you get a complete Excel sheet, and it has coordinate information from that exact image, exact location, and you can have all those images and you can load it up into that app. It contacts directly the Google Map or Google Earth, and you can put all those images there. So that is the very easy way to do it. So yes, so now I think those sites that you mentioned as a pilot exactly sequence.
Any other questions?
Okay, so thank you again.
Okay, I'll give it to you.